All right, so today we're going to do a deep dive into the world of microchips. You know, those tiny little things that basically run every device that we use nowadays.
Absolutely.
We all kind of have heard the basics, but today we're really going to get into it and see how they're impacting the global landscape.
Yeah, we're talking geopolitics, we're
Yeah.
talking economics,
Yeah,
even military power.
it's a fascinating story. And we have a great article that we're going to be referencing for this called Are Microchips the Oil of the 21st Century?
Oh, great question.
It really is, isn't it?
Yeah.
I mean, are we really looking at the new oil? Is this the thing that's going to dictate, global power in this century?
It very well might be. To answer that question, I think we really have to start by looking at just how crucial these chips are. I mean, what are they really? We hear the term, we throw it around a lot, but what are they?
Yeah, I mean, I think about my smartphone and my computer, but okay, forget all that. Just help me understand what a microchip actually is.
Okay, well, imagine a city, but shrink that city down to the size of your fingernail. Okay, etched onto this little plate of silicon that we call a wafer.
Oh, wow.
That's essentially what a microchip is. It's like this tiny city, billions of transistors, resistors, capacitors, all working together, incredibly complex network, just processing information at lightning speed.
That's pretty amazing. I mean, why is smaller better when it comes to these things?
Well, that's the thing. Miniaturization really allows us to just pack more and more transistors, into the same space, more processing power.
Oh, I see.
And that fuels, everything, right? Faster smartphones, artificial intelligence, all that stuff. But smaller components also use less energy.
Oh, that's good.
So our devices are more efficient.
Okay, that makes sense. But why are these things causing such a stir on a global scale? Is it just about who can make, the smallest and fastest chip?
That's definitely part of it. But it's really the fact that the ability to produce these chips, it's become this strategic asset. It's almost like controlling a vital resource, kind of like oil was in the 20th century, right? That was the lifeblood of the global economy. You could say that today, microchips are playing a similar role.
Oh, wow. Interesting. So who are the major players in this global chip game?
It's interesting. The landscape's really evolved over time. Initially, it was the US. The US was dominant. But things started to shift when Asian countries, especially Japan, started entering the market. They had cheaper production, focused on exports.
Oh, so it's kind of like manufacturing moving to wherever the costs are lower, huh?
Precisely. And this created some tension. I mean, back in 1987, President Reagan, he actually banned Japanese chip imports to protect the American industry.
Oh, wow.
It's kind of a move that echoes what we're seeing happening today.
1987. That's fascinating. So did the U.S. ever manage to regain its chip-making crown after that?
Not quite. But instead, this fascinating partnership emerged. Taiwan, through a company called TSMC, became a really crucial player. And TSMC, they specialized in actually manufacturing the chips for companies that designed them but didn't have their own fabrication plants, the fabs.
So, okay, so companies like Apple, they would design the chips, but then TSMC would actually make them.
Exactly.
Oh, wow.
And it turned out to be an incredibly successful strategy. I mean, TSMC really became the world leader in what we call chip foundry, mastering all these incredibly complex manufacturing processes. Very few could actually replicate it.
So basically, everybody became reliant on Taiwan for these cutting-edge chips.
Yeah, you could say that. And this reliance is actually at the heart of all the geopolitical tension that we're seeing right now, especially between the U.S. and China.
Right, right. Because China's a major player in tech as well. So how does that factor into all of this?
Yeah, well, China's been investing heavily in building up their own chip-making capabilities. They want to reduce reliance on these foreign suppliers, especially in these strategically important sectors, like artificial intelligence and military applications.
And I'm guessing the U.S. is not exactly thrilled about, China's growing tech prowess.
You got it. I mean, in response to these ambitions that China has, the U.S., under President Biden, enacted this thing called the CHIPS Act. And what that does is it essentially restricts the export of these advanced chips and this chip-making equipment to China. It's a move designed to slow down China's progress, basically, and maintain the U.S.'s technological edge.
So we've got these two superpowers kind of locked in this chip war, with Taiwan kind of stuck in the middle. That's a precarious situation.
Yeah.
And this is where that potential blockade of Taiwan comes into play, right?
Yeah, exactly. The potential for conflict between China and Taiwan is a major, major concern. And not just for those two countries, but for the whole world. Because if China were to actually blockade Taiwan, it would severely disrupt the global supply of chips.
Right, because we've established that pretty much everyone relies on Taiwan for these things.
Mm-hmm.
So what would the fallout from something like that even look like?
Oh, we're talking a potential economic earthquake. I mean, smartphones, computers, cars, medical devices, you name it, all industries that depend on these advanced microchips. They would basically grind to a halt. The impact would be felt globally. It's really hard to even imagine the ripple effects.
That's a scary thought. So this isn't just some abstract tech issue. It really has real-world implications that could affect everyone. Knowing all this, what's the global response been? Are we just sitting ducks waiting for this potential crisis to happen?
Not exactly. There's a growing awareness of the risk of relying on a single source for such a vital resource. So there's this push for diversification.
Okay, tell me more about that. What are countries doing to reduce this dependence on Taiwan?
It's a multi-pronged approach, really. The European Union has its own version of this CHIPS Act. They're aiming to boost their domestic chip production capacity. And we're seeing countries like the US and Germany. They're attracting these major chip manufacturers like TSMC and Intel to set up fabs on their soil.
So it's almost like this global game of musical chairs with everyone trying to secure their own chip supply.
Yeah, it's a good analogy. And this scramble for these chips, it's reshaping the entire landscape of the industry. It's creating new alliances. It's fueling competition.
This is fascinating. It's amazing to think that something as tiny as a microchip could have such a profound impact on global affairs. There's got to be even more to this story, though, right?
Oh, absolutely. I mean, we've only just scratched the surface here. We haven't even touched on things like the ethical considerations, the environmental challenges, and some of the mind-blowing advancements in chip technology that are on the horizon.
Well, it sounds like we've got a lot more ground to cover in this deep dive, so stay tuned, everyone. We're going to explore these fascinating aspects of the microchip world after a short break. All right, so we're back, and we're talking all about this global scramble to secure those chip supplies. But what does that actually look like, in the real world? I mean, it can't just be as simple as building more factories, right?
You're absolutely right. It's a huge challenge. I mean, building those fabs, those fabrication plants, they're incredibly expensive.
Oh, yeah.
And they take forever to build. We're talking billions of euros.
Yeah.
And years of construction just to get one of these things up and running.
So it's not just like flipping a switch. What are some of the other hurdles that countries are facing when they try to ramp up their chip production?
Well, one of the biggest bottlenecks is the specialized equipment that's actually needed to manufacture these chips. I mean, this stuff is incredibly complex, and there are only a handful of companies around the world that even produce it.
Oh, wow. So even if you have the money to build the factory, you might be stuck waiting for the equipment.
Exactly. And then on top of that, you got the human element. You need highly skilled engineers and technicians to run these fabs, to keep them running smoothly. It's not just the facilities. You got to have the talent to back it up.
So it's like this high-tech puzzle. You've got the money, the equipment, the expertise, and I imagine the raw materials too.
Oh, absolutely. And let's not forget the whole geopolitical dimension. Those countries that are currently dominating chip production, they're not really all that keen on sharing their knowledge and their expertise.
Right, because they see it as an advantage.
Exactly. It's a strategic advantage for them. If everyone can suddenly make their own chips, well, that advantage just disappears.
So even with all this push for diversification, there's still a lot of competition.
Oh, tons of competition.
And secrecy.
Oh, yeah, a lot of secrecy in the industry.
That's interesting. So it's almost like this weird paradox, right? We've got this global need for these microchips, but then we also have this fierce competition to control the technology and the supply chains.
Absolutely. It's a delicate balance.
Okay, so let's zoom out for a second. Let's think big picture here. If this trend continues, where countries are becoming more self-sufficient with their chip production, what happens to the industry in the long run?
That's the big question, isn't it? I mean, on the one hand, more diversification, well, that could lead to more stability.
Right.
We wouldn't be as vulnerable.
No more single points of failure.
Exactly. We spread the risk out.
But wouldn't that also mean less collaboration and less innovation? I mean, if everybody's doing their own thing, wouldn't that slow down progress?
It's definitely a valid concern. The industry has thrived on this idea of collaboration, companies specializing in certain areas and working together to kind of push the boundaries.
Right, right. So how do we balance these competing forces, the need for security and the desire for progress?
That's the million-dollar question, right? Maybe we'll see a hybrid model where countries are developing their own domestic capabilities, but they're still engaging in these strategic partnerships. To share knowledge, to share resources.
So co-opetition?
Exactly.
Cooperating and competing at the same time.
Yeah, exactly.
And this shift, this would probably lead to some new centers of innovation popping up.
Oh, absolutely. We're already seeing that happening, like with the EU and their focus on next generation chip technologies.
Yeah, that's interesting. Okay, so we've talked about economics, we've talked about geopolitics. What about the environmental impact of all this? You mentioned earlier that chip manufacturing, it's not exactly the greenest industry.
Yeah, that's true.
Can you talk a little bit more about that?
Yeah, so producing these chips requires insane amounts of energy and water.
Wow.
I mean, the fabs themselves, these massive climate-controlled facilities, they just suck up electricity. And then you've got the waste issue, the chemicals and materials that are used in the manufacturing process. Well, those can be harmful if they're not handled properly.
So the more reliant we are on these chips, the bigger our environmental footprint becomes.
Unfortunately, yeah.
That's kind of a dilemma, isn't it? We need the chips, but we also need to protect the planet. Is the industry doing anything to address this?
Yeah, I mean, there's a growing awareness of the need for sustainable practices. Companies are investing in renewable energy sources to power their fabs. They're looking for ways to reduce water consumption, minimize waste, and a lot of research is going into new materials and new manufacturing processes that are less harmful to the environment.
So it's a work in progress, but at least some progress is being made.
Yeah.
So it sounds like the future of this industry is going to be shaped by a lot of things: economics, geopolitics, but also our commitment to sustainability.
I think that's a really crucial point. The choices that we make today are going to determine what this chip landscape looks like tomorrow. And those choices have to factor in not just our technological needs, but our responsibility to the planet.
Well said. It's clear that this tiny little ship, it's at the center of this web of complex issues. But beyond all the challenges and the geopolitics, there's this sense of incredible innovation and possibility.
Oh, absolutely.
This is really cool stuff.
Yeah.
What's coming next? What's on the horizon for these microchips?
Well, one area that's generating a lot of buzz is the development of these new chip architectures.
Okay, so we're back, and you were telling us about these new chip architectures and all these advancements on the horizon.
Yeah, so we were talking about how silicon's been the king for so long.
Right, yeah.
But as we're trying to pack more and more transistors onto these chips, silicon's kind of starting to hit its limits.
Oh.
So, for decades, the industry's relied on silicon as the material for chips. But we're starting to see the limits of that as we try to cram more and more transistors onto a single chip.
Right, because we were talking about how miniaturization has been key, but it sounds like we're hitting a wall.
Yeah, there's a physical limit to how small you can make a transistor using this traditional silicon-based technology.
I see.
So researchers are exploring all these new materials and designs that can kind of push past these limits.
Okay, so what are those materials? What are we talking about here?
Well, one promising area is what we call compound semiconductors.
Compound semiconductors.
Yeah, and these use combinations of elements like gallium nitride and indium phosphide.
Okay.
And these materials, they have properties that allow for faster switching speeds and higher power handling capabilities compared to silicon.
So we're talking about chips that are not just smaller, but they're also fundamentally different in how they work.
Absolutely. And these advancements, they open up a whole new world of possibilities. Like, for example, those gallium nitride chips? They're already being used in 5G base stations and electric vehicle chargers. Because they're so efficient, they can handle all that power.
That's cool. But you also mentioned these new chip architectures. What did you mean by that?
Right. So think about how a traditional computer works. It processes information sequentially, like one step at a time. But researchers are now being inspired by the human brain, which processes information in a massively parallel way.
So instead of a single processor doing everything, you would have multiple processors working at the same time.
Exactly. Kind of like a network of mini brains.
Oh, wow.
And that's actually the idea behind something called neuromorphic computing.
Neuromorphic computing.
Yeah, it's a mouthful. But these chips are designed to kind of mimic the structure and function of the human brain.
Why?
You have all these interconnected nodes that can learn and adapt.
Okay, now that's getting into science fiction territory.
I know, right?
But I can see how that kind of processing power would just totally revolutionize things like artificial intelligence.
Oh, absolutely. I mean, neuromorphic chips could lead to AI systems that are way more intuitive, more adaptable, and more energy efficient.
Wow.
Imagine AI that can actually learn and solve problems in real time without needing all this massive data or processing power.
That is mind-boggling. So it sounds like the future of microchips is going to be shaped not just by new materials, but by completely new ways of even thinking about computing.
Yeah, I think that's a great way to put it. I mean, we're at this turning point where materials, science, nanotechnology, neuroscience, they're all coming together. It's opening up all these crazy possibilities.
It's pretty exciting to think about all the potential applications. But, with all this talk about these advanced chips
Hmm.
and artificial intelligence, are there any ethical considerations we need to be thinking about?
Oh, that's a huge question. As these chips become more powerful and these AI systems become more sophisticated, we have to really think carefully about what it means for things like privacy, security, and even, the nature of work itself.
Right, because if machines can start to learn and adapt, what does that mean for, human jobs and skill?
Exactly, and that's a whole other conversation.
It is. That deserves its own deep dive for sure. And I think we've covered a lot of ground today in understanding this really complex world of microchips. So as we wrap up here, what's the one key takeaway you want our listeners to walk away with?
I think the most important thing to remember is that microchips are not just some components in our devices. They're really at the heart of this global ecosystem that's shaping the future of technology, the future of economics,
Yeah.
and even the future of geopolitics.
That's a powerful thought. It's easy to take these little tiny chips for granted, but they really are the driving force behind so much of what's happening in the world.
And that's why it's so important to understand how this industry works. What are the challenges? What are the opportunities?
Yeah, absolutely. Well, on that note, I think we'll wrap up this deep dive into the world of microchips. It's been a fascinating journey, and I hope our listeners feel empowered to stay curious and keep learning about this ever-evolving field.
Couldn't agree more.
Thanks for joining us, everyone. And be sure to check out the show notes for links to the article we talked about and other resources to keep feeding that curiosity. Until next time.